Ladies and gentlemen, good afternoon. Very warm greetings to each and every one of you. Welcome to the webinar on refined gold quality master alloy critical parameter to jewelry performance. I am Nilambari, the MC of the event. On behalf of the organizing committee, Evental Global Advisory Private Limited, we extend our appreciation for your presence today. This is the second series of master alloys. And the earlier webinar gave us an overview on what the master alloy is and how they are made, the importance of the raw material and refining, and some of the characteristics of popular master alloys. This webinar would revisit some of the concepts which we have covered earlier and also develop deep into aspects linking master alloys with jewelry performance. We have two finest experts in the industry to present the webinar. Let me introduce them to you now. Mr. Ankur Goyal, President Works, MMTC-PAMP India Private Limited. Mr. Ankur Goyal has over 29 years of experience in precious metal line with 18 years in gold and silver jewelry manufacturing through lost wax investment, casting method, and 11 years in gold and silver refining and minted coin production. He has in-depth knowledge of gold and silver metallurgy, master alloys, gold and silver refining from Mine Dore. Mr. Ankur Goyal is BE Metallurgy from IIT Roorkee, ME Metallurgy from IISc, and alumnus of Senior Management Program of IIM Kolkata. And we have Mr. Debashish Banerjee, Vice President Works, MMTC-PAMP India Private Limited. He has 30 years of experience with a demonstrated history in the contribution to the precious metal industry. He is skilled in budgeting, operation management, team building, leadership, and sustaining changes. He is a strong engineering professional with a BE in metallurgy from Jadavpur University. They would make a presentation for about 20 to 25 minutes. After that, we would have a question and answer session. So feel free to post your questions in the chat box, and we will try to address as many as possible within the limitation of time. With this, I hand over the session to Mr. Ankur Goyal, President. Mr. Ankur Goyal, President, Works, MMTC-PAMP. Over to you, sir.
Yeah, thank you, Nilambari.
Thank you,
and thanks, Event Global, for giving us this opportunity and partnering with us to at least share some of the recent findings which we have encountered as we have gone through various phases of life. And some of the findings are recent ones. We keep doing at MMTC-PAMP, we keep doing certain trials, and we keep evolving various things which come into our domain. What we found was refined gold quality is having its own merits and demerits, and simultaneously master alloys. When we are manufacturing jewelry, there are two main processes for manufacturing jewelry. One is by handmade, which the karigars do, and second is by the lost wax investment casting. In both these cases, there are, in handmade, there may be 5-10 parameters. In a lost wax casting, I can list down 15 various process parameters which can affect the jewelry performance. But what we see is most of these defects which can come in a jewelry manufacturing or in a final jewelry can be mitigated if we are using the right kind of refined gold and if we are using a right kind of master alloys. Other processes like what Debashish will highlight to you as we go along, like sprue design, the mold temperature, investment casting, and all those things can be mastered as we go along. But these are the two main things which are sort of external to any manufacturer. Other things are all their internal processes and they can do it. So without wasting much of a time, let me run through you. What we would like to do is I'll run through you what are the various refining process. Most of you are in this field and would be knowing refinery process. Here we will highlight what is the key differences which we see in two of the refining process which is being used currently in the world, and how impurities affect the refined gold. Simultaneously, Debashish will run you through what is master alloy. We have already, most of you know about it, but we'll just refresh that mind. But our emphasis would be more on what are the various parameters which MMTC-PAMP uses. MMTC-PAMP started manufacturing master alloys in last 3 years with always there are competitors who have been manufacturing for last 20 years. But what are the various, we want to just highlight or expose you to various other elements which are being used to manufacture this master alloys, what we are doing, how we are catering to the how we are trying to solve various issues with the master alloy. And it is that we are there. The idea is to just share you what we are there and some of the other products which MMTC-PAMP is doing. And before I go into the refining process, I would like to highlight what our total group is. It's just a short introduction where the parent group, which is the MKS group, and we derive all our quality parameters. And what you will see as you go along this thing, purity is the key to everything. It's the key to gold. It's the key to master alloys. And that is something which we have learned from our Swiss partners. The MKS group is worldwide. We have our MKS main group at Geneva. We have one factory at PAMP, another factory at MMTC-PAMP India. We do have our network of minted coins MTB, which is at USA, and we also are at the Gold Avenue. And what we strive for as MMTC-PAMP, and this is something you will see as we go along, everything would be related to these things. We do refining. We also are LBMA accredited. So what we make is a gold which is of high purity. And we keep on focusing on innovations, not only in the terms of technology, but also in order to bring various things to the customers in the country. We are London Good Delivery. We are accredited to BIS. Even both me and my laboratory head are also associated with BIS in the Precious Metal Committee, helping BIS to make various standards. We are also accredited to Social Accountability 8000. We have not written, we have RJC certification, Responsible Jewelry Council. And right now, I think we are the only ones who have the chain of custody certificate, so that we can supply you gold, which currently the world is calling, the Indian country is calling as green gold or ethical gold. We do have various awards in our forum. It is a one-stop shop, I would say, to the total gold ecosystem. We deal with bullion, minted products, master alloys. We are just going into industrial product. And one thing is, because of our processes, we can always work out, even giving you standard reference material, even going up to 5/9 gold. Services, I'm not going much into services. We are into digital platforms, scrap refining, hedging, hallmarking. We have also ventured into hallmarking, and we are doing quite a number of pieces for the country hallmarking, and set up a very good setup for hallmarking. We do assay testing for various laboratories. In short, I would say bullion, scrap refining, minted products, master alloys. We also are into gold monetization scheme. These are some of the datas. Our total annual capacity is 300 tons of gold and 600 tons of silver. This is something a bit on MMTC-PAMP and the MKS group. Now coming to our main topic, what I can say, and everybody knows, there are two main processes for refining. One is electro refining or electrolytic refining, which is called out, and the second is the chemical refining. Chemical refining per se has been in the country, or not in the country, I would say in the world, for years and years. And just in short to explain, you have unrefined gold, which comes from the mines, having various impurities like selenium, tellurium, iron, platinum, which PGM metals are there. You dissolve that material into aqua regia using sodium metabisulfite. You precipitate that gold. It's a simple process. And once you precipitate the gold, you get the cemented gold, you melt and make bars out of it. This is a process which has been used worldwide. But What I would say, it requires a lot of expertise. As you go along, I'll show you how using this in a very controlled way, you can really get good gold. But what is happening is that controlled way is sometimes missing. While in case of an electro-refining process, it's the same process. It's a slightly different process. Sorry, you have the doré, you make the anodes, you go through the electrolysis setup of anode and cathode, where the impure anode gets dissolved into the solution and pure gold ions get deposited onto the cathode. The consumed anodes are remelted and made back into anodes. And from the sponge which you get, which is, I would say, 49 plus and devoid of any impurities, are melted into grains, which are then melted in a furnace to make bars. So this is a basic thing which is required. But what we see is, if you see what we see, what is the basic difference? Electrolytic refining you can do in a large scale. Chemical refining also you can do in a large scale, but normally people set up small scale units, 5 kgs, 10 kgs, 50 kgs. While electro refining, you can even go to up to a 1 ton a day with a small areas of setup. You can get 4.9 and above. Normally, when we are doing, we get 4.95, 4.96, and in certain cases, we also get 5.9 gold. In case of chemical refining, it has its own limitations. Impurities is a challenge. Electro refining, since there are ions getting deposited, there's no impurities going onto the cathode. While in case of chemical refining, we do find certain impurities, and that's why I've always mentioned that if you do it in a controlled way, the impurities can be limited. Definitely operating cost, chemicals are less while electricity cost is higher. In case of chemical refining, it's the other way, where you have operating cost because of chemicals is higher, but less electricity. This is a crucial thing why electro refining has not been so prevalent, because it does require a high inventory, which is not much required for chemical refining. Effluent can be controlled, and the gold and the jewelry here, I would like to say, and you'll see in the subsequent slides, the jewelry produced by electro refined gold are much better than produced by chemical refining. Chemical refined gold, if it is manufactured by a controlled process, will not have its impurities. This is what is we would like to say is what has been, we have done a number of trials. We have done a number of trials to see what happens to the impurities. What happens to the impurities when it is getting refined. If you see an electro refining gold, you get 496 with limited silver and copper into it. Then when we convert it into 999 for making 100-gram bars or 1 kg bars, or 995, in most of the cases, and everybody in most of the cases are adding silver, and sometimes some people add copper, but very few add copper. But what you see, this is a typically gold from 900, we add silver because we have converted 496 to 999, and in this case we almost add 1 kg gold, we almost add 5 grams silver for coming, and rest is copper. We also did certain experiments, and we also tested some of the golds which are coming in the country. We did find in certain cases when we did a chemical refining experiment, we were not able, and if you're doing in a very controlled way, we could reach to this first column, I would say, with limited amount of impurities. But if we not refine it in a controlled way and we refine the whole things, some of the impurities do get precipitated. So you will sometimes see if most the gold which is refined chemically may contain impurities like copper is okay enough. Copper may not result into a lot of problems. We'll see what Devashish will say at a later date. But iron, manganese, silicon, tin, tellurium, and zinc may cause problem to your jewelry. And you won't realize it. It will be there, and that will result into some black spots, hard spots, porosity, and all those things which will be there. So what we see is you do get consistent gold, and this is something what we have been doing, and I hope everybody else also in the country is doing. We give extra gold and extra purity to the silver, and whatever silver we use to convert to 995 is also 49 pure gold. The most important thing is to avoid them of impurities. And as you see, these are the major difference we see. We did do refining of chemical refined gold, and we didn't do the control mechanism, and we did find inclusions coming. And because of impurities, you can see the differences in the casting tree, which is there. You can see the differences even in the pink gold. How is the finish, which is there. You can see there is cracking. Sometimes there's cracking happening in the jewelry, and you all are aware of. And when we make the cast bars of 100 grams, we do find that there are slags inclusions which are coming. We did check with few of the a few of the people, and they did said that they do face some of the problems. Sometimes some of the manufacturers refine the gold which they receive, and then they take it for the next process. So here, what I would like to add is by chemical refining in a controlled way and by electrolytic refining, you can get gold. And that gold, as you see, once I'll give my mic to Debashish, who will highlight to you how that gold will affect your jewelry as we go along. Off to you, Debashish.
Thank you, Ankur sir. Am I audible?
Yeah, you are audible.
Okay. So can we move on with the slide, sir?
Yeah, 1 second.
Well, we all know that to make a jewelry, we need master alloy. I need not define here, because we all are from the jewelry industry, that what is the role that master alloy is playing, and what are the caratage that we derive when we mix the master gold to get from the pure gold. We cannot make jewelry from pure gold or silver. Hence, we need to mix some other metal, either in pure form or in master alloy form, to get to the desired carat, and then execute it to get the jewelry which we are looking for, either through the casting route or through the fabrication route. And depending on the master alloy, the properties changes, as well as the color changes, like yellow, white, rose, green, etc., which you are looking for. So we'll jump this slide, because this is a basic slide. Now, when you are talking of master alloy, as Ankur sir had pointed out, there are many good players already in the market, especially a lot of good international players are already here. Now, when we say we are manufacturing our master alloy, these are some of the salient features which we incorporate into it. Number one, silver is the prime ingredient in the master alloy, and hence we are very specific when you are looking which silver to be used. We use exclusively 5-9 silver. Where does it come from? It comes from our own refinery. We have our own refinery. We are LBMA accredited silver refiner, and hence we can get this material which we are using. The other raw materials, we are importing it with strict control over the quality parameters, and to mention list among this is copper. Our copper is ox-free, or that is oxygen-free, having oxygen less than 10 ppm, while the other metals like lead, zinc, etc., which we will show later on, are all having 3.9 minimum purity, which we use as ingredient. And since all this material that we procure are procured under controlled on the vendors of high quality, they are without any lead or cadmium or any other elements that may interfere in terms of their deleterious, as well as the gold that we already supply are also free from this, which Ankur sir has already spoken about. We have our the entire manufacturing operation in MMTC-PAMP for the alloys, in addition to our refining, are absolutely under a strict quality control parameters. And as a result, these are alloys are already giving a lot of good effects to the jewelry manufacturers in terms of reducing the defects like porosity, gold loss, homogeneity, etc., irrespective of the color and caratage. We have a complete setup of the laboratory chemist, which has all the precision equipments like ICPs, then spark spectrophotometers, backed by our chemists of highest quality, and our metallurgical experience of refining helps us to analyze the root cause with a lot of in-depth, which we can then pass it on into our product as a solution provider. And being in India, which gives us definitely an advantage over the other alloy importers, that we can easily customize the products at a very short turnaround time. And our technical team is available anytime you call up, somebody will be replying you back. And we are consistently working on this to improve the feedback, because we know this is a sort of service industry and we have to be on our toes to make you happy. And while packing also, we take care so that it is not getting oxidized and etc. By adding silica gel and etc. to take care of the humidification process. So these are some of the basic features which we have embarked on when you started the journey of producing master alloys. Now, sir, next slide, please. So if we have a look at the periodic table, though it looks very big, but the fact is only few of the elements only have proved to be beneficial to be used in conjunction as master alloy. Most of them are not usable still, or the human or the mankind has not been able to find out how to use them. I hope that we get more such metals, which gives us more benefits as we move along. So next slide. Okay. So now, when we are talking of master alloys, a master alloy is actually a combination of many elements. And not only the quality of the elements are important, which I spoke just a few minutes back, but also each element has got a role to play, which actually attributes to the desired quality, which attributes to the color that is imparted to the final jewelry. Number one, silver. Why is silver used? Silver provides us the luster, and it is used to control the color. It gives us the typical shiny and lustrous white color which we want the jewelry to have. It is a unique metal. Of course, it has its own issues, but without silver, for the gold jewelry, none of the alloys have proven to be successful. Copper, it is another ingredient which goes in hand to hand with silver. It increases the hardness by solid solution hardening. In metallurgical, we call it solid solution hardening. And at the same time, it attributes to certain degree of ductility, malleability for mechanical purpose. When you want to draw a mechanical wear or you want to draw a strip, you need certain hardness. So if you are only having silver, you will not be able to get it. So copper gives that work hardening effect when you are using this in conjunction with silver. But you have to properly maintain the ratio so that you would get the desired color. Otherwise, with more copper, you will get a pinkish color. And at the same time, you will tend to have an oxidation effect, which will affect the jewelry color as well as its homogeneity. And the results may vary when you go for a fire assay report of your final jewelry in hallmarking or XRF testing. Zinc, this is another element which is added to improve the castability, or we call it the form filling. Basically, in a simpler language, it gives more fluidity of the melt, helps to get the design filled up very fast, which in common language we call castability, and it gives improves the tensile strength also. That means it gives a balance of the ductility if you want to go for a mechanical application, and also improves the color. it gives a typical color it attributes, but the zinc has to be maintained within certain ratio. Otherwise, it will then tend to form an oxide, which will exhibit as a defect when you try to polish it. So the balance is very important, how much zinc you are adding to it. Even extra zinc can give to some losses during melting, which will actually lead to a carat creep and is a concern, especially when you are working with higher caratage. Now, silicon. The silicon is primarily called as a deoxidizer, though I differ when I call it a deoxidizer. It has a very good affinity for oxygen. So when you are doing a silicon addition like a doping, it tends to come to the surface of the casting and tends to form a layer which tends to prevent the oxidation. So one thing I missed out, that zinc has a very good antioxidation property. So zinc forms a vapor over the liquid metal surface and prevents any oxygen to penetrate the metal when the metal is getting filled up and it is in touch with the investment surface, the casting surface. Now, silicon and zinc, they work in a synergistic way. That means they work in a combination, and this helps to get less oxygen absorption in the metal, and at the same time, it reduces the surface tension. As a result, the interface reaction between the mold investment surface and the cast surface is reduced, which helps to improve the roughness. That means reduced roughness, reduced gas porosity due to sulfur dioxide liberation from the investment powder, and also a better shine on the surface, which has effect on the polishing, on the gold loss in its polishing, pre-polishing stage. So silicon and zinc needs to be balanced. While they have all their detrimental effects, like if your silicon increases much, it will form cracking. So you need to be balanced. You cannot just add, and it has very limited solubility in gold and silver. It is soluble in copper. So when you are talking of silicon, you have to be very particular about what copper silicon ratio you are maintaining, because the silicon needs to be soluble. Otherwise, it will form a segregation and lead to cracking of your jewelry. Germanium, this is a new age deoxidizer, much more effective than silicon. It can be added independently or in conjunction with silicon, and it gives the best deoxidizing effect till now among all the deoxidizers used, but it is costly, and it has, of course, over certain quantity, it will have its own deleterious effects in terms of forming inclusions. Going to nickel, nickel is added for bleaching. That means it imparts a white color. But nickel, we know that nickel melts above 1500 degrees centigrade. So naturally, when you add nickel, you have to be careful that you need to maintain a proper temperature, so that the porosity or the gas metal reaction, the mold metal reactions doesn't affect your jewelry. But basically, nickel is a bleacher. Boron, this is a deoxidizer, is a mild deoxidizer which can be added. It's a little reactive, very difficult to get dissolved, but it has its effect. And at the same time, perhaps it also has some grain refining effect through dispersion hardening method, which we metallurgically call. So boron is also used as in small quantities to act as a deoxidizer as well as grain refiner. Cobalt, it is a good grain refiner, which increases the hardness due to dispersion effect, and especially for handmade alloys, where you want hardening, you want a work hardening index to go higher as you work, you do add cobalt in controlled way. Again, if you add the cobalt beyond certain range where it is no more soluble, it can segregate and form precipitates, which will act as a stress raiser and can form cracking also. While indium, it's a low melting alloy, low melting element, which is added for improving the fluidity and ductility. It lowers the melting temperature by forming a very low melting phase and helps in improving the fluidity. It has to be added in small quantity, and especially it is applicable where you want to substitute the cadmium in case of shoulder alloys, because cadmium is banned. So you can use this indium to make shoulder alloys as a substitute of cadmium. But it is again a little on the costlier side. You need to have a careful about. Now gallium, it is a liquid metal at room temperature, and it is used sparingly. I won't say it is used in a very prevalent manner. It has its own hardening effect, difficult to handle because it is already in a liquid state. Now all this combination needs to be properly judged before you make a master alloy. Not only the quality of the material of these elements or the metals that you buy and add, but a judicious blending is important so that you arrive at the correct characteristics in terms of your hardness, in terms of your ductility, in terms of your castability, in terms of your colors, oxidation property, which we try to impart to our master alloys, backed by the knowledge of our metallurgists and our laboratory. Sir, can we move on to the next slide? Typical hand manufacturing process, we won't elaborate this, where you go for this rolling or wet drawing, and finally you could do a blanking, soldering to get a handmade jewelry. Sir, the next one, the casting process. The most prevalent process where you go to the lost wax casting method. You all are very well aware handling with this. So I would prefer to skip this slide and go to the next one, which is of much more relevance. Now, here we will try to have our correlation between the major defects that we face with how the gold quality plays an important part in it, as well as what the alloy composition has to be. On both these two fields, that means MMTC-PAMP produces superfine gold, LBMA accredited. At the same time, it produces alloy. So we have a dual responsibility of providing our customers the proper gold, at the same time proper alloy. Now let us look at the first, that is gas porosity. We are most of the time the casting is an issue where you get lots of gas porosities, very micro porosities, which is very difficult, and especially when you go for a 10x magnification. You find that there are so many that you can't, how many you will be able to repair. And the pieces move on with between shoulders, lasers, productivity goes down. Now, how a gold quality? Now, gold, if you say, if the gold quality, that when you pour the liquid, the gold, after your precipitation into a mold, where you have applied lots of used oil or soot for lubrication purpose, and then you take out that gold, which is actually laden with carbon, and you don't clean it properly with alcohol or acetone, and you just use it for your making in alloys and etc. You are, especially if you are doing a direct premixing and casting it, then this carbon in the gold, which has got entrapped, will react. It will form carbon monoxide gas, and that will lead to that will get entrapped into the liquid metal. When that liquid metal gets solidified, it will try to come out of the surface, leaving small micro porosities. So when you are actually pouring this, it will also happen that if you have so the first slide. Sir, we have gone to this slide. First slide. Slide number 23.
Ankur sir? Ankur sir? He said.
Yeah, continue, Debashi.
Slide number 23. We have moved on to the next slide. So we want to move back.
Sorry. Yeah.
Okay, so this is so the gold needs to be very much free from this, and also it should be free from lead, tin, bismuth, antimony. Every element should be properly within the ASTM specification. Now, how the alloy contributes to gas porosity. So if you are not using a proper balance of silicon and zinc, then at the interface, you will have gas liberation. The calcium sulfate from the interface will get degraded and will produce sulfur dioxide gas that will lead to sulfur dioxide related porosity. So the proper silicon zinc balance is very important. Okay. And the other, and if of course, if your carbon is there from your investment powder, it will definitely lead to gas porosity. Now coming to the shrinkage porosity, the pure gold doesn't have much of a value to add to it. But yes, if your alloy is having more nickel or cobalt, which requires more higher temperature, definitely it will contribute to this because it is requiring higher temperature. And to compensate that, you have to go to designing of your sprues location and design at the correct location. Now, inclusions as hard spot. If your gold is precipitated with ferrous sulfate, you will, and you are not washing it properly, you will get iron. And at the same time, if it is having iridium, it will definitely lead to this inclusions entrapped into the cast surface. So when you will polish, you will find that this is coming out as a hard spot on your polished surface, especially the lapping surface. From the alloy, we can say that the copper needs to be deox quality. That means the copper needs to have 10 less than 10 ppm, while the silver that you use, it should be electrolytical origin and it should have less than 50 ppm, ideally less than 50 ppm oxygen, so that there is no oxygen present where the copper can get oxidized and can get included as your oxide. So, and if you in your alloy, you are using iridium, then the iridium very likely will form clusters and will lead to this hard spot. So this is the from where the inclusions can come. The slide number 24, please. Now, now coming to the oxide. So when you are precipitating the gold by chemical way, if your precipitation process is incorrect, you will also get copper. And that copper will pass on as chlorides and finally turn to oxides in your metal. And that oxide will get included in your cast surface. So a proper controlling of this oxide is very important when you do precipitation. Now, fortunately, in electrolysis, this doesn't happen, and hence we can say that electrolytic gold doesn't have this. Now, from the alloy, again, I say the copper should be free from oxygen less than 10 ppm, and the silver should have less than 50 ppm. Now, if you get oxygen, which can lead to copper oxide, it can form gas pores, it can form inclusions, and even in mechanical working, when you want to do annealing, these oxides can get converted and you will get pores during the hydrogen treatment or ammonia treatment. Now, cracking, if your gold is containing lead or selenium or tellurium, it will form embrittlement, and this embrittlement will lead to your cracking, and you can get cracking during rolling or your casting. So all elements must conform to ASTM. Again, in cracking from the alloy, the copper silicon ratio, which I mentioned, is very important. Otherwise, it will form to coarser grains and orange peel effect, graining, all these things, and lead to your more gold losses during polishing. The roughness, pure gold doesn't have to this much addition, but when you add zinc and you add silicon in a balanced way, the cast surface will be free from roughness. It will be smooth, it will be shiny, and no oxidation effect. And at the same time, you will get an uniform color all around the surface. So this is from how the alloy can contribute. So next slide. So these are the range of alloys where you produce. Definitely, we are focused more on the yellow till now. But we have a range covering everything, and we are ready to serve you. The next one. Now, one advantage that being in India, what we do, we'll try to explain 3 cases where the turnaround time has been very quick, and we can do multiple trials with you so that we ultimately we will carry on the rest.
So thank you, Debashish, for sharing various things. What I would like to add, and we'll just take 2 minutes and then we'll open the floor. What I would like to add is whatever parameters or the alloys or various metals which is being used to produce master alloys is to aid or to avoid the various defects. It is always good to make these master alloys with pure metals. And what happens when we start avoiding these defects, or we use a gold which is refined in a proper way? What happens? We save on rejections. We save on rework, which is one of the prevalent thing in the jewelry industry. And when you save on rework, when you save on rejections, what you see is paying a bit extra on refining charges to get a proper refined gold is the key of the whole thing, I would say. So what you can get is, even if you have a 10% rejections, you are saving on the whole thing. So that is one thing. And simultaneously, before I close, we do have a full testing facilities at MMTC-PAMP, and that is what we can offer to the country, where we can help you in finding out what are the issues which you are facing and solve those issues. So we do have a testing for the gold, the silver with various machines, and we can also supply you high standard material which you can use for your own testing. Gold wire, which is 49 plus, or even in certain cases, if you want to test your gold as 49, we can supply you 59 wires. We can supply you ingots which are free from silver as per the IS 1418 standards, silver grain, silver wires, buttons for your testings. So what we say is we are here to help you out, to solve your problems. If you're facing it in gold, to solve your problems, we are facing it in master alloys, we are there. So I just now open it to the this thing. Only one thing I can say is what Debashish pointed out: master alloy using of all these metals is not easy. If you use them in excess, you'll find only rejections. So there is a certain minimum level or a threshold with which we will have to use this metal. A high silicon in an alloy will result into cracking, and you'll find all your tree has cracked. So be mindful of that fact. So I think I now leave it to open any questions which are there. Thank you.
Thank you, Mr. Ankur. Thank you, Mr. Debashish. It was indeed a very interesting presentation, and we came to know a lot about master alloys and their specifications. So we are open to the questions and answer round. So I'll put up the first question, sir. If you can hear me, am I audible?
Yes.
Okay.
Yes,
So first question is from Mr. Suresh Mathu. He has mentioned that for Indian-made casting machine, open casting need more deoxidizer, silicon or in alloy. For fully automatic machine, closed casting machine need low deoxidizer. So how can we choose the alloys as per the machine type?
Okay, we do understand the limitations of an open casting machine, because we do see oxygen entering into the melt. Here, definitely, one important thing is to use the right kind of master alloy. But the other important thing I would suggest in this case is also to have an expert doing the casting. Even with an open casting, but if you have a proper cover over it, you can mitigate this issue of oxidation. Definitely a closed casting where you have a inert atmosphere vacuum, or even when you add a nitrogen, which gives a better atmosphere to it, is not equivalent to an open casting machine. But definitely an alloy can help. But I would say alloy can help to a certain extent, because adding a high amount of deoxidizer will also have its own effect, but simultaneously you need to have an expert. Debashish, if you would like to add anything onto this.
Yeah, am I audible?
Yeah.
Okay, as truly pointed out by Mr. Matthew, in close casting system, ideally, and especially when you are talking of yellow gold, you should not require any deoxidase. I am talking about the ideal case, because your crucible inside is made of graphite, which itself is a deoxidizer. And again, you have a sealed chamber, which you are already have flushed out, and you have a nitrogen umbrella there or argon umbrella there. So you shouldn't require a deoxidizer, but we do require no deoxidizer there. But at the same time, as you correctly pointed out, when you come to a closed casting machine, the parameters are not so controlled. The top surface of the metal is exposed to the atmospheric oxygen. And you know, as per Sievert's law, at higher temperature, the solubility of oxygen in liquid metal or any gases, including oxygen, is very high, and then they tend to come out. So the key to is your zinc content, which you have to retain. So try to use a proper borax cover and try to use a judicious temperature. Don't overheat, don't keep it in a prolonged way so that the zinc flies off. Increasing silicon to a beyond a level will be very risky, because you will end up with cracks. So the zinc is the key. You have to retain the zinc, which will actually help you to prevent the deoxidation. And with your results, you will be able to give feedback to the alloy manufacturer, who will be able to customize depending on the results. And again, it depends on which carat you are using, because that has a direct relation with the temperature and the casting phenomena, which in turn actually dictates the composition that the alloy manufacturer will provide you. So we have to be very careful in maintaining temperature and the borax cover properly.
So since you were answering to the question of Mr. Suresh Mathur, he has some additional question to that. So he is asking, how can we find the correct alloy code? And we have mentioned the oxidizer level in the oxidizer level in each alloys.
Yeah, Debashish.
Yes. Now, there are two deoxidizers we primarily talked about in casting. Since we are talking of casting, one is silicon and one is zinc. We have to understand that they walk hand to hand. It's not that I simply add zinc and it will compensate. If you increase, you'll end up with oxide inclusions. If you increase silicon, you'll end up with cracking. So first of all, this zinc, normally it is is prescribed that it should be within 3% in the final alloy as an setup. But it has lots of other values also which needs to be added. The melting losses and etc. has to be calculated. So only and similarly, silicon has a very, very low solubility, or rather almost nil solubility in silver and gold. It is soluble in copper. So the copper has to be there if you want to use as a silicon as a deoxidizer. But again, the silicon you cannot increase, because after certain range, the silicon itself gets segregated at the grain boundary and lead to your cracking. So when you go back to your manufacturer, you need to be observe what is the surface that you are getting from your casting. Under the same conditions, same cast weight, same investment powder, same burnout, and you have to record the surface phenomena. Even you can just get the results of the crucible residue that you are getting at the end of each heat. And mind, this has to be done meticulously for each carat. The same result for 14 carat cannot go for same result for 18 carat. So need all these you need to give to the alloy manufacturer, who in turn will give you, if not in one, maybe in second or third, the correct composition. Your feedback is most important.
Okay, thank you, sir. So another question is from Mr. Arun. He has asked, what causes loss in the 10 carat casting, particularly in the white and the rose gold?
Rose gold losses, you have harped a string, which is very difficult. Pink gold is a very difficult alloy to handle, especially if you are mentioning 18 karat. Okay. The metallurgy is very difficult to handle. It's very much prone to casting if you don't quench properly. So in 18 karat, we have to, as an alloy manufacturer, you have to have some zinc to give it a little ductility, to give it a little softness. Otherwise, when you will polish, you will find it difficult. Zero zinc is not possible. So limiting the zinc is the only thing which will actually help you in getting the losses under control. While coming to what was the other question in white gold?
What causes loss in the 10 karat casting, particularly in white and rose gold? He's asking.
Yeah. Now 10 karat is high alloy. As you can see, 10 karat is around 42% gold and the rest alloy. So you can understand that you are actually handling more alloy. So when you are actually handling more alloy, you have more zinc in that. And it is very likely that the temperature demand of depending on the alloy, especially when you're talking of white, there is nickel. So nickel will demand more temperature. So the only thing to reduce this losses during the casting, first is pre-melting. During the pre-melting, you need to be very careful that it is under controlled conditions so that the zinc is not lost. In that case, you are actually having a higher caratage gold before you land up into your casting. Now, when you go into your casting, you need to improve on the sprueing effect. The sprue needs to be corrected at multiple locations or at the heaviest section so that you can compensate for the low temperature that you are dealing with a higher velocity of metal which feeds it. Keeping the temperature low and getting the form filling is the key to low gold losses in 10 karat or any white gold which is having nickel. And for red, I have already mentioned the scope is limited because you hardly in these alloys where you have so much copper, you have to have some zinc. So again, if you can try, some of them tries, don't do pre-alloying in case of red gold. You just simply add the gold and the alloy and do a direct casting. You can try that. So you eliminate one step of pre-alloying and you can prevent the zinc losses.
Okay. Thank you, sir. So we have a question from Mr. Edward, and he has asked how to improve the reusability and keep the surface quality after the recast.
I can take that.
Okay.
So the most important thing when you are using a recast jewelry is always to add fresh metal to it, fresh alloyed gold to it. Normally, it is said that, and we have experienced a lot, is if you are using a 50% fresh and 50% reused gold, it will be it is better. It will give you a good this thing. But the important thing also in this is you need to clean the gold or the, if you are doing a investment casting, you get the tree, you need to clean it very properly. Because if you with a proper water jet and with short blasting and all, because if you leave some of the powder in it, then you might get defects which are there. You might also have to study how is your tree, what is the finish of the tree which is cut, tree which is there. If it has porosities, if it has inclusions of carbon, then you have to be very careful when you do the melting. And it is always better, as I said, 50% and 50%, and then you can reuse it.
So we got another question from Mr. Arun, who has asked about the 10K casting, particularly in the white and the rose gold part. So he has asked that what causes less tunch in the 10 karat pink and white casting, and what causes dent in the porosity and less smooth surface in a big plain gold piece?
What was the first question? What causes?
What causes less tunch in the 10K pink and white casting?
Well, if you are talking of, if you are saying, say tunch, that means should I take as the assay value, the carat value?
Yeah, what he's asking is in 10 carat pink and white casting, what he's observing is the purity is going less after after production.
Okay. Now again, it comes to the fact that if I can say, because 10 carat alloy, alloyed gold contains more alloy. And since the gentleman is talking about white gold, so that means definitely there is nickel. Okay. Now, when you're having nickel, see the nickel melting temperature is over 1500 degrees centigrade. Okay. While in gold and copper, we are more or less at 1065, 1063. So when you are adding this, definitely the casting temperature requirement plus the superheat required to do a form filling is more. But when you are actually casting and cooling down, there is a huge segregation happening. What do you mean by segregation? Because the nickel comes out very easily and tends to get separated out. So it is very likely that inside your tree, the central part, the gold is not going anywhere. It is actually getting redistributed, which we call as segregation. That is, some part is actually getting rich in gold, while the some part is getting richer in lower in gold. Unfortunately, what Mr. Arun has said, that he's getting the pieces as a lower gold. So I would suggest in this case, try to, number one, reduce the casting temperature a bit. And the second, try to shorten the tree a bit. Because when you are having a higher tree, higher weight of the tree, the segregation phenomena will be more. So try to make a reduced tree weight or a reduced high weight and a lower temperature. With a faster cooling, you will perhaps be able to avoid the segregation and see this as a less. And a good way to study is to cut or put two or three small places at different parts of the tree and do an X-ray from the same tree and see how it has varied from top to bottom. You will come to know actually how much segregation is happening, and accordingly you can adjust the tree weight or the button weight. That I can say. And what was the second question?
The second question was, sir, just a sec.
So it says what causes dent porosity?
Yeah, sir. Yeah. Correct.
What causes dent porosities and less smooth surface in big plain gold pieces?
Yeah. Okay. Now, when you are talking of big plain pieces, now I am assuming that we are talking about casting. So inside actually the inside of the investment powder is giving a replica on the cast surface. So you need to improve your investment surface. The more smooth it is, you will get a better surface. Leave aside the alloy, leave aside the gold. Improve your investment surface. Follow the correct principles like the proper hardness, 2 hours, use of only DM water, a water that is devoid of any chlorides in your investment process, a 2-hour process, proper burnout, proper dewaxing, and then you will get a very smooth investment surface. And as a result, when you are actually casting, you will get a better surface finish in your on your casting surface. Of course, if you are using a high temperature at that time, or your alloy has something which demands high temperature, then at the interface you will have mold metal surface interaction reaction. As a result of that, lots of gases of sulfur dioxide will be liberated at that surface, which will create ripples at the surface, causing small roughness, which will show as roughness, and you will face losses when you will be doing pre-polishing. So first improve your investment. That will solve your problem majorly. And then you can work on the temperature. Alloy has the third role to play in it.
Okay. Thank you, sir. So we go back to Mr. Suresh Mathu again. So he has another question. He's asking SWY004 alloy is open casting machine or closed casting machine. It's good if in open, but in closed casting, it's getting blackish and crack. May I know the reason why it is so?
Yeah, SWY004, we have done a similar thing to our what our customer want to one of our competitors made. But this alloy, we know that it contains a certain silicon percentage, which is not very helpful. So we always advise people to go with SWY003 for your closed casting, which is having a much more balance. SWY004 was originated, its original version from our competitor was originated in 1960s for Mexico. So only that part has remained. They have not promoted, they have faced a similar problem, but since some of our customer wanted a substitute, you did that. And they don't want to change, but it is having some issues due to higher silicon content. So we always suggest that you use it for open casting. In closed casting, the silicon growth is perhaps promoting the this casting growth. And while we have a substitute SWY003, which can serve you better. So I suggest you change over to it.
You are on mute, Nilavli.
He's asking for a suggestion in alloy data sheet. So mention the deoxidizer level, percentage or level for SWY004, low or medium or high. It will definitely help in choosing as per the machine type. So he's asking the specifications on that.
Yeah, we can work that out. Actually, the deoxidization is one parameter which is there, but there are other parameters also in the alloy. So the suggestion has been taken. We will see how we can incorporate so that the customers get a clear idea of the various alloys which are there. We'll definitely work that out.
Okay, sir. So we have a question from Mr. Alpesh. I don't know whether. So he's asking, please advise for platinum solder alloy. So will it be a specific question on your subject line?
Yeah, actually, we have not ventured into platinum right now.
Okay.
Definitely in near future, we will be doing it out. What I can suggest is definitely you can check with few of the imported manufacturers, and as what Devashish had pointed out, using of the low melting elements can help you in reducing the melting point of platinum, which can be used for as a solder.
Great. I think we have addressed.
Devashish, if you can add to some of the elements which they can use.
The first part is we are not into it, so apologies. The second part is, yes, platinum soldering is a little more trickier than many things because when you are actually doing platinum, you are at a much higher temperature. So you need to have a proper filling agent, which is at a much lower temperature. In gold, it is perhaps easier because you have indium, where you can use and it is workable there. But for platinum, it is much more critical where you cannot perhaps go with indium because indium is at 400, platinum is at 2000. So I understand that the issue is there, and unfortunately at this moment we will not be able to answer these questions. We will take it up.
So, we would like, then we have almost addressed all the questions. So I would like to have a closing remarks from both of you, and we can after that close the session.
Devashish, you can start and then I can take over.
Yes.
Yeah, first of all, thanks to all of you who have spent time here. Thanks to the organizers for allowing us to speak on behalf of MMTC-PAMP. MMTC-PAMP, I will sincerely request all of you to look at MMTC-PAMP as an ally in your journey in the jewelry field. We are not only refining gold, we're not only refining silver, we are not only making alloys, but we also want you to think how we can help in your refining. Where you have scrap gold, you do refining, you land up with poor gold quality. We are here. We can serve you. We can serve you with a gold, pure gold. We can serve you with the alloyed gold, whatever you want, in the form you want. You want us grains, we give you grains. You want us to give you strips, we will give you strips. So we are here in the long run to serve you, and whatever problem, anything related to metal, related to testing, related to standards, related to digital gold, we are here. So look upon us as an able ally in your long run. And thank you very much again from myself. Over to Ankur sir.
So yeah, thank you and thanks. First, I would thank Nilambari and thanks to the event hall, and Srivasta is not here, but thanks. We had a discussion in November when I was in Bangalore that we would continue with this series, and definitely we will now keep on coming to you back by seeing this overwhelming response. Thank you for coming and listening to us, and hope we tried to make it. There's so much to share. I would say it's a whole world of technology. There's so much to share. We have tried to make it short, and in our next coming up webinars, we will try to address specific issues. I have already written down both mine and Devashish's mail ID. So any questions or anything, you can come back to us. We'll be happy to help you out. We are available in 12 centers all over India. And what I can say is refining is a difficult, it seems easy on an onset, but refining is a difficult option where it's not only refining, but it's also taking care of all the other parameters, all the effluents, all the emissions which are there. And MMTC-PAMP has invested quite a bit. We are here to give you what kind of gold. We have also got the various accreditations so that if somebody is requiring a recycled COC gold, that can be given. So we do have the LBMA certification. So what I'm saying is we are here to really help you out in the technological field. Be free to contact us anytime. We can share our experiences and our main idea is to give you a best quality gold which can lead, and also master alloys. Our idea of coming into master alloys was to reach to you so that we can help you in terms of giving you the best quality gold which can help you to reduce the rejections and you get a good jewelry. Thank you.
Thank you, sir. So one request, if you want to share the presentation, one can ask you over mail or Devashish sir over mail, or can mail me if they need the presentation copy.
Yeah, we will let you know. We'll let you know.
So with this, I thank each and every one of you for taking out time, taking out the precious time and making this webinar successful. Thank you very much, sir. Thank you, Devashish sir. Thank you, Ankur sir. We hope we meet soon again.
Thank you.
Thank you very much. Thank you, sir. So the networking lines will be open. I mean, like the chat box will be open for another 20 minutes. If anybody wants to do the network and use this medium. Okay. Thank you so much.
Thank you.
Thank you.